The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and cover Objective 4A Part 2. And so let's go ahead and get started. Suppose we have the following equation. 4x plus y equals 12. And the instructions say for each of the following equations, complete the given ordered pairs. We have this and this and this. So we have three incomplete ordered pairs. Notice our equation has two variables, x and y. X corresponds to the first coordinate of each ordered pair. Y corresponds to the second coordinate of each ordered pair. So to complete the first ordered pair, since x is 0, we're going to put 0 in the place of x. And we get 4 times 0 plus y equals 12. 4 times 0 is 0. 0 plus y is y. So we get y equals 12. So our first ordered pair is 0, 12. That ordered pair is a solution to this equation. Any questions about that process? All right, we're going to do the same thing again, only now we're going to use the second ordered pair, this one, where x is -3. So we get 4 times -3 plus y equals 12. 4 times -3 is -12. -12 plus y equals 12. We'll add 12 to both sides of the equation and get y equals 24, which is going to go up there. So we get -3, 24. That ordered pair is a solution to the equation 4x plus y equals 12. Again, any questions about this? Okay, let's take a look at the third ordered pair. We're supposed to find x when y is -8. So -8 goes in the place of y, and we get 4x plus -8 equals 12. We'll add 8 to both sides of the equation. 4x equals 20. We'll divide both sides by 4, and x equals 5, which goes right up there. So we now have three ordered pairs that are all solutions to this equation. Now, in the last chapter, or objective, whatever you want to call it there, we solved equations in one variable, typically in x. Here we're solving equations in two variables, but they're giving us the value of one of the variables to substitute into the equation. All right, anyway, any questions about this example? All right, let's take a look at another example. Here we have the equation 6x minus y equals 10. And we are to complete the following ordered pairs. Let's see here. Oops, oh, sorry, I was looking at the wrong thing there. Better guess it's time to put on the glasses. Okay. X is 1, x is 0, and then y is +8. So if x equals 1, we get the following. 6 times 1 minus y equals 10. 6 times 1 is 6, so 6 minus y equals 10. We'll subtract 6 from both sides of the equation. So negative y equals positive 4, but negative y is not y. We need to divide both sides by that implied negative 1 coefficient. So y equals negative 4. Any questions about that example? So this ordered pair is a solution to this equation. Okay. Let's take a look at the second ordered pair. X is 0, so we get 6 times 0 minus y equals 10. 6 times 0 is 0. 0 minus y equals 10. 0 minus y is just negative y. Negative y equals 10. Divide both sides by negative 1. Y equals negative 10. So there is another solution to this 6x minus y equals 10 equation. All right, and then finally, y is 8. So we've got 6x minus 8 equals 10. Adding 8 to both sides, 6x equals 18. Dividing both sides by 6, x equals 3. So here we have 3 ordered pairs, 3 solutions to this equation. Any questions about that example? All right, let's switch over to the WAMAP board. And let's take a look at question number 1. It says, for each of the following equations, complete the given ordered pairs. Enter integers or reduced fractions, no decimal answers. So in this particular part of WAMAP, it doesn't accept decimal numbers. We have the equation 3x plus 2y equals 4. And we are to complete the ordered pairs 10 comma something, something comma 2, and negative 6 comma something. Okay.
Mr. Mayor, we can't see the other screen.
You can't see the WAMAP screen?
We can't see what you're writing.
Oh, right. Yes, thank you. I'm going to switch back here in a second, but thank you, Brandon. Because sometimes I do forget to push the right things. Okay, so here we have that equation. I just wanted you to see what it looked like on WAMAP. We're going to just do the exact same thing we did. When x is 10, we get 3 times 10 plus 2y equals 4. 30 plus 2y equals 4. Subtract 30 from both sides. 2y equals negative 26. Divide by 2, y equals negative 13. So our first ordered pair should be 10 comma negative 13. Going on, if y is 2, we get 3x plus 2 times 2 equals 4. 3x plus 4 equals 4. Subtract 4 from both sides of the equation. 3x equals 0. Divide by 3, x equals 0. So 0, 2 should be our second ordered pair. And finally, if x is 6, 3 times negative 6 plus 2y equals 4. Negative 18 plus 2y equals 4. Add 18 to both sides. 2y equals, let's write that a little better there. And 18 equals 22. Divide by 2, y equals 11. So our ordered pair should be 10, negative 13, 0, 2, and negative 6, 11. So now over here, 10, negative 13, 0, 2, and negative 6, 11. And there we go. All right. Any questions about that process? So in WAMAP, question 2 and 3 are exactly the same idea. You've got ordered pairs, except instead of being written across horizontally, now they're written vertically. This one's horizontally, same idea. Okay. Any questions about that? Do you need any more examples of that? All right, then let's go on to the next type of questions. Take a look at question 4. It says, for the given graph, what is the value of y when x is 1? Okay, what is the value of y when x is 1? I'm going to go back to my whiteboard screen for a minute here. So what they're saying is, and I'm just going to draw a rough sketch. So we've got this graph, okay? It says, what is the value of y when x is 1? It would be as if though they had said, excuse me, complete the ordered pair. X is 1, y is what? Look at the graph. Oh my, sorry about that. Look at the graph, and on the graph, find a point that has an x value of 1. Okay, so x equals 1 is right there. So right there would be the point with an x value of 1. Do you see that? So what's the
-2.
right? The corresponding y value is -2. So what you're doing, you're finding a point on the line that has the given coordinate and then finding the other coordinate. Let's do one more of these. Let's see. For the given graph, what is the value of y when x is -3? X is -3 is right here. Okay. What's the corresponding y value right there?
-3.
-3. You okay with those? Any questions there? All right. So here's another couple of examples. These are all the same kinds of questions. Given one of the points, find the other. Boy, there's a lot of it in there. How about this one? For the given graph, what is the value of x when y is 2? Well, y equals 2 would be right there. What's the corresponding x value?
2.
Right, 2. Okay. So we all right with that idea? You need any more examples there? We're good to go? Okay. Yeah, again, there's a whole bunch of those. Okay, now it says for the following equation, complete the given ordered pairs, then draw a line using 2 of the ordered pairs. All right, so what I'm going to do, I'm going to go back to the whiteboard screen here to do our calculations. Okay. So we have the equation x plus y equals -1. And we are to complete those 3 ordered pairs, okay? So if x is 4, putting 4 in the place of x, we get 4 plus y equals -1. Subtract 4 from both sides of the equation, y equals -5. Starting over, if x is 0, 0 plus y equals -1. 0 plus y is just y equals -1. So there's our second ordered pair. Finally, find x when y is 3. X plus 3 equals -1. Subtract 3 from both sides and we get -4. So before I switch back to the other screen, any questions about how I found those 3 ordered pairs? Okay, so now we're going to go back over here. The first point was 4, -5. The second point was 0, -1. And the third point was -4, 3. Okay. Any questions there? So what I've done so far is basically the same thing we did earlier at the top of this assignment, okay? But now we're going to go further. Here's the dealio. This equation is called a linear, as in line, a linear equation. As you can see, we have multiple solutions. In fact, there are an infinite number of solutions to this equation because we could pick any real number for x and solve it for y and create an ordered pair. Or we could pick any number for y and solve it for x and create an ordered pair. If we take all of the solutions, all of those ordered pairs, and we plot them on the same graph, it forms a straight line. Now, it says here, draw a line using two of the ordered pairs. It doesn't matter which two. I'm going to go ahead and use the first two. So we're going to draw. So we're going to go starting with 4, -5. And then, let's see, 0, -1. X is 0, Y is -1 is right there. Okay. Now, this line doesn't have arrows on both ends of it, but if you were graphing it by hand, I would tell you to put arrows on it to imply that it goes both directions forever. Okay. Notice that the point -4, 3 is also on the line. They said just to plot 2 points. So I don't know what'll happen if I plot the third one. I'm not going to, but all 3 of these points are on that same line. Okay. Are we okay with that? All right. Let's see here. Let's get a similar question. Let's see here. That gives us, it's the same equation, but different ordered pairs. I wanted a different question. Let's go down and we'll do this next one. Actually, here, let's do this one. Let's do this one. That one looks a little more complicated because of the fraction. All right. So we've got y equals 3/4 x plus 1. Then we've got the ordered pair 0, something, -4, something, and something, +4. Okay. So now I'm going to switch back to the whiteboard screen. And let's complete these ordered pairs. Let's see, if x is 0, I get y equals 3/4 times 0 plus 1, which is 0 plus 1 or just 1. If x is -4, y equals 3/4 times -4 plus 1. -4/4 reduces to -1/1. 3 times -1 divided by 1 is -3. And then plus 1, which is -2. And finally, y is 4. So 4 equals 3/4 x plus 1. We'll subtract 1 from both sides of the equation. 3 equals 3/4 x. Oh, we have an equation in one variable. The coefficient is a fraction. So we're going to multiply both sides by the reciprocal of the coefficient of x. On the right side, the 3's and the 4's reduce down to 1's. So I have 1 times x, or just x. On the left side, the 3's reduce down to 1's, and I get x equals 4. Are you okay with this so far? I want to point out something. Notice that this ordered pair, when we put in the -4 for x, we got a nice answer. Even though we had a fraction here, because the denominator is a 4, if I have an x value that's a multiple of 4, like 0, -4, negative 8, 4, 8, 12, and I plug it in there, it's going to reduce out nicely and give me an integer answer. All right. Again, any questions here before I switch back to the other board? So let's see, we have 0, 1, negative 4, negative 2, and 4, 4. All right. Again, draw two solutions. I guess I don't need to click on this. It's already highlighted. I'll tell you what, let's use the second 2 points this time. So negative 4, negative 2 is right there. And then we're going to, what, 4, 4. Notice that 0, 1, the third point, is on the line. Okay with that? All right. The rest of this assignment is just more of the same. You've got an equation and 2 variables. You're going to complete the ordered pairs, then use 2 of the ordered pairs to draw the graph. And that's what all of these are. So you've got really 3 types of questions in this assignment, but they're all interrelated. The first one is given equations, complete the ordered pairs. Then giving a graph of a line and given one of the coordinates for a point on the line, find the other coordinate. And then finally, just like the first set of equations, find the 3 ordered pairs, plot 2 of the points to graph the line. Any questions? Do you need any more examples of any of these types of problems?
Could you do another example of the fraction part?
Okay, let's see if we can get one that will, that one has the fraction. Let's see, are there any others here? Well, let's put another one in there and see what happens. Yeah, it keeps giving us the, you know what I'm going to do? I'm going to switch to the other screen and use a different one because it looks like everyone that we generate is going to have that 3/4 or negative 3/4, and I want to use a different fraction. So give me a minute here. Okay. Let's see here. How about this one? Y equals 1/2 x plus 5. Okay. And we're going to complete the following ordered pairs. Negative 4, something, 8, something, and something, 0. All right. So far, so good. Let's take the first ordered pair where x is negative 4. So we're going to have y equals 1/2 times negative 4 plus 5. Notice that negative 4 is a multiple of 2. So things are going to reduce out nicely. Negative 4 over 2 is negative 2 over 1. So I've got y equals negative 2 plus 5, which is 3. So far, so good. All right. Second ordered pair. Find y when x is 8. Y equals 1/2 times 8 plus 5. 8 over 2 reduces to 4 over 1. Y equals 4 plus 5, which is 9. So there's our second ordered pair. Third ordered pair. Find x when y is 0. So we get 0 equals 1/2 x plus 5. we'll subtract 5 from both sides of the equation. -5 equals 1/2 x. Multiply both sides of the equation by 2, or 2 over 1. We get -10 equals x. All right. Now, I've run into a small problem in that my graph doesn't go out that far. It doesn't go to -10, 0, or 8, 9. Okay, darn. So I've got a couple of options. I can pick a different problem. I can change the scale on my graph. Well, let's see here. Or I could switch to a different screen. I'm going to switch to a different screen. Okay, so hold on. We're going to take this information, which I'm going to write down here. Y equals 1/2 x plus 5, -4, 3, 8, 9, and -10, 0. Okay. Give me just a minute here. All right. Do you see a screen that has what looks like graph paper on it?
Yes.
Okay. So this is, if we were doing this by hand, let's say, not using like WAMAP, but you were using a piece of graph paper, you would draw a y-axis and an x-axis, okay? And then let's see here. We'll put a scale on it. And right here, this is going to be, there we go. There's a 5 and a 5 and a -5 and a -5. Okay. So I've established that each square is 1 unit. Our equation was y equals 1/2 x plus 5. The 3 ordered pairs that we found were those. Okay. Oh, let's see. How about if we pick the first pair and the last pair? Because we're going to use 2 of these pairs. So we'll use this one and this one. Okay. All right. So -4, 3 is going to be right there. And -10, let's see, 1, 2, 3, 4, right here would be -10. 0 is right there. Okay. Any questions about that?
No.
So now let's draw the line. If I can do that here, let's see here. It goes up 3 and over 6. So, hang on a second here. Actually, you know what? I'm going to draw the other point as well. 8, 9, and I'll show you why I want to do that in a minute. So 8, let's see here. This particular program is kind of picky, so I'm going to line things up here. 8, 9 is right there. So what I'm going to do now is draw a line using the program rather than my ruler. And so I'm going to start right there. And that should go through both points. There we go. And as I mentioned before, I'm going to put arrows on it. All right. What I wanted to do is I wanted some points, a point beyond the 2 points, because when you use this tool to draw the line, it just starts at the point, and I wanted to extend it out. Anyway, I don't know if that makes sense. Anyway, So there is another example. Are you okay with that? Or do you want yet another example? It's up to you.
One more, please.
Again, you want one with fractions, right?
Yes, please.
Okay, let's see here. We already used a 2 and a 3. Let's use this one. So how about y equals 4/5 x minus 3. Okay, this time I'm going to write it in a table format instead of ordered pairs. Remember we looked at that, how it's just a different way of writing ordered pairs. And tell you what, let's use 0 and -5 and +5 for x values, okay? And now we're going to draw a graph. And we'll draw the scale. Let's see, there's 5, 10, 5, 10, -5, -10, 10. Okay, so 5, 10, 5, 10, -5, -10, -5, -10. Okay. So our first ordered pair, x is 0. So let's see, if x is 0, we get y equals 4/5 times 0 minus 3. Well, anything times 0 is 0, and 0 minus 3 is -3. So we get 0, -3 as our first ordered pair. Any questions about that? Okay. If x is -5, we get y equals 4/5 times -5 minus 3. -5 over 5 reduces to 1 over, or -1 over 1. 4 times -1 is -4, minus 3 would be -7. If x is 5, we get y equals 4/5 times 5 minus 3. The 5 is reduced to 1 over 1, and we have 4 minus 3, which is 1. Okay. Tell you what, let's throw in another value that isn't a nice one. How about, let's use x is 3. Okay. So y equals 4/5 times 3 minus 3, which is 12/5 minus 3. Ooh. Okay, let's see. 12/5 minus 3. To combine those, we need, what do we need? We need a common denominator, right? Which is going to be a 5. So we'll have 12/5 minus so many fifths. We'll multiply by 5/5, which will give us minus 15/5, which is -3/5. Okay. Did you follow what I did there? Did I lose anybody? So we're good? All right. I'm going to use the first 2 ordered pairs to plot the graph, but I'm going to show you that these other 2 points are solutions. So 0, -3 would be right there. -5, -7, let's see, would be right there. Okay. So let's see here. I need this. I'm going to start right there. Okay. And then, see, I need to put arrows here. All right, notice the 0.51 is right there. And the 0.3, -3/5, though it's kind of hard to tell, it's right there. Do you see that?
Yeah.
Okay. Any more questions? All right. Well, that's it for today. I'm going to stop the recording.